students, I hope you all are safe in the pandemic. Now let us start today's lecture of class 11 chapter functions. In my last lecture we have discussed about the definition of functions and domain range. What do you mean by codomain image of a functions? Today we continue with types of functions. Now let us recall the definition of a functions. Please students, recall the definition of a functions. What do you mean by functions? When we say that a mapping or a relation is a functions, suppose A be a set and B be another set, then suppose A be a set and B be another set, then F be a mapping from A to B such that all elements of set A must be mapped with an unique element in set B. Suppose A is mapping with 1, B is with 2, C is with 3 and D is with 4, and simultaneously B cannot be mapping with 2 and 5 simultaneously. Then this cannot be say if B mapping with 2, B also make a functions with 5, then we cannot say this is a functions. Suppose the definition says that if A belongs to A set and B belongs to B set, then A, B belongs to F such that A belongs to A and B belongs to B. All elements of set A must be a domain in set B, must be a pair in set B. And the another condition says that if A, B and A, C, A, B and A, C, A, B and A, C belongs to F, be equal to C. If A, B and A, C belongs to F, then belongs to F, this shows that B must be equal with C, because one elements in set A must be mapping with one unique element in set B. Okay. Now let us discuss the various types of functions. At first we discussed about one functions. One functions is also called injections functions. One functions. What do you mean by one functions? A must be mapping with the if A be a set and B be another set, A be a set and B be another set, then A, B, C, D and here E, F, G, H are the elements of set B. Then the injection function says that A mapping the if F be a functions from A to B, F be a functions from A such that there are 1-to-1 mapping. A map with 2, E, B mapping with F, D mapping with G and C mapping with H. Then there is a 1-1 functions. Each elements of set A mapping with unique element of set B. If I say if G be a functions from A to B, if here A set and B set such that here A, B, C, D, E and here 1, 2, 3, 4, 5, 6. Then if A mapping with 1 and B with 2, C also with 2 and D with 3 and E with 5, then this is not a 1-1 functions, because here both B and C mapping with 2. Here B2 and C2. If G is a mapping B2 and C2 belongs to G. This is not a 1-1 functions. 1-1 functions is said unique element of set A mapping with unique element of set B. Let us discuss one examples here. I have already told you students, please do your worksheets and ask me your doubt. I have promised you to complete your syllabus and would like to solve all your queries which you may kindly drop in my comment box. Here let f be a functions from R to R, from real number to real number, such that fx is equal to x cube plus 2. Then we have to find that if this is a 1-1 functions or not. If fx is equal to x cube plus 2, if we say that x and y be two arbitrary elements, if x and y are two arbitrary elements, elements of R, then in such a way that fx is equal to fy, then this means x cube plus 2 is equal to y cube plus 2, which shows that x cube is equal to y cube. This implies that x must be equal to y. When x is equal to y, then can only fx is equal to fy. This functions fx x cube plus 2 is a 1-1 functions. One single elements of set R is mapping with one single element of set R. Then this is a 1-1 functions. Now discussed about another type. This is 1-1 functions is also called injection functions. The type 1 is 1-1 functions is also called injection functions. Which functions? Injection functions. Then discussed about onto functions. Onto functions is called also surjection functions. This is onto function. Onto function is also called a surjection functions. In which conditions we say this is a onto functions. If a functions, please students note down the definitions and be attentive while I am teaching. If a functions f such that from A to B such that is said to be a onto functions is said to be an onto function, is said to be an onto functions. In which conditions we say A and B are on functions f from A to B is called to be a onto functions. The first condition says that if every elements of B is have a pre-image in set A. If every element, in which conditions we say this f is a onto functions, so where every element of set B must be a order pair in set A. An order pair must be an order pair in set A, and then we say that this is a onto function. This means f of A is equal to set B. Other conditions we say that f of A is subset of B, but in case of onto functions we say that of A is equal to B sets. Means every element of set B must be a order pair in set A. No element will be untouched. Suppose let us take examples. Suppose f be a functions from A to B such that and g be a functions from x to y are two functions represented here. Now let us discuss whether they are onto functions or not. Now keep it here. And discussed about whether these two functions are onto functions or not. Now here the diagram says that A be a set and B be another set, A be a set and B be another set, such that A, B, C, D are the elements of set A. A, B, C, D are the elements, C, D are the elements of set A, and E, F, G, H, E, F, G, H are the elements of set B. Then if A is mapping with F and B is mapping with G and C is mapping with F and D is mapping with H, if F be the functions from A to B, is this functions is an onto functions? If this function f satisfies the conditions of a onto functions? No, because here E is left here, who doesn't have any other pair in set A. Look at here, E is left here. Here A, F belongs to F, B, G belongs to B, G belongs to F, and C, F belongs to F, and D, H belongs to F. But here E do not have. Is there E here? Is there E here? E is untouched here. E doesn't have any other pair in set A. This shows that the functions f doesn't satisfy the conditions of a onto functions. This means f is not an onto functions. Now discussed about another examples. Here A be a set and B be another set in which K, L, M, N are the elements of set A, and here in case of B there are P, O, P, Q, R are the elements of set B. Here K map with O, L map with P, N map with Q, and N map with R. This is here G is a mapping from A to B. Then here no elements. Now let us check whether the functions G satisfies the conditions of an onto functions. Because the conditions of an onto function says that each element of set G is in. Here look at here, all elements. Here K, O, L, P, M, Q, N, R means no elements in set B left which do not have any other pair. This means the functions G is an onto functions. This satisfies the conditions of an onto. Now let us discuss another examples for better understandings. The first we discussed about the injections functions or one functions. Here this is surjection functions or onto functions. Now let us discuss an examples. Here let f be a functions from R to R such that fx is equal to, here the condition says fx is equal to x cube plus 2. Then here f of x, let x and y be any arbitrary, let y be any arbitrary codomain of elements. If y be any arbitrary element of R, means codomain or range. Then here fx is equal to y. Fx is called x cube plus 2 which equal to y. This shows that x cube is equal to y minus 2. X is equal to y minus 2 whole to the power 1 upon 3. If y is a real number, then y minus 2 whole to the power 1 upon 3 is also a real number. This shows that x also belongs to R. This means for any y belongs to R in the set of codomain, there must be a domain in set R. There must exist an x in R. This shows that f the mapping R to R is an onto functions. Is an onto functions because it satisfies the conditions of an onto functions. Then at first we discussed about injection functions or one functions. Then this is onto functions or surjection functions. Now let us discuss about bijection functions, the functions which satisfies both the conditions of one and onto. Now first injections, then surjection, then the third type is called bijection functions. Third type is called bijection functions. Bijection functions, this means the functions which shows that the functions which satisfies both the conditions of one and onto. The function which satisfies both the conditions of one and onto. This means the functions which is both one and onto are is called bijection functions. Now let us discuss, suppose A be a set and B be another set, A be a set and B be another set, F be a mapping from F be a functions from A to B such that A, B, C, D are the elements of set A, and here 1, 2, 3, 4 are the elements of set B, where A mapping with 2, B with 1, D with 3 and C with 4. Look at here. Here these functions F satisfies. At first let us check for 1. Here A mapping with 2, B with 1, C with 4 and D with 3. All elements of set A have a unique match with set B. All elements of set A have a unique match in set B. All elements of set B have a unique pair in set A. This shows that if B mapping with 1 and C also mapping with 1, then this is not one functions. And onto function says that all elements of set B must be a domain in set A. Here B, all elements of 1 has an order pair B, 2 has an order pair A, 3 has an order pair D and 4 has an order pair C. No elements of set B left here which do not have any domain in set A. This shows that the functions here F satisfies the function F satisfies both the conditions, both the conditions of one and onto. This means this is both injections and surjections. This means this is a bijection functions. Now let us discuss another examples. Now let us discuss some more examples. If we say here G is a mapping from X to Y such that X has an elements X1, X2, X3, X4 and Y with an elements Y1, Y2, Y3, Y4 Then here, if x mapping with y1, x2 mapping with y3, x3 mapping with y2, and x4 mapping with y4, then this is an 1 1 and on 2 functions, because each element of set y has a unique pair in set x, and no elements in set y is left here which do not have any domain in set x. This shows that G satisfies both the conditions of 1 1 and onto. Then this shows that this is an bijection functions, means it is both injection and surjections. Now let us discuss about many one functions. This is four types. Fourth type is called many one function. Many one functions. What do you mean by many one functions? Suppose here f be n mapping from x to y such that x has elements x1, x2, x3, x4, and y has elements y1, y2, y3, and y4, and here x1 mapping with y2, x2 mapping with y1, x3 mapping with y2, and y4 mapping with y1. Then here this is called many one functions, because here x1, y2, and x2, y1, and x3, y1, and x4, y2 are the elements of set F. This means here y2 has two codomains or image in set X. y2 has x1 and y2 has x4. Here y1 has also two codomains, x2 and x4. This means this is many one functions. Many number of elements of set X mapping within single elements in set Y. Then this is called many one functions. Then here this is called many one functions. Now let us discuss about some examples. Here the example says that if A, B and set which contains -1, 1, -2 and 2, and B be another set which contains 1, 4, 9, 16. Then here f be a functions from a to b such that fx is equal to x square. Then here f of -1 is equal to 1 and f of 1 is also equal to 1. Then f of -2 is also equal to 4 and f of 2 is also equal to 4. Then this is an example of many one mapping. Many map with single elements in set P. Many mapping with the single element in set P. This is an example of many one. Now I think students you must understand the thing which I have to teach you. At first we discussed about injection functions, then surjection functions, then bijection functions. Here many one. Then now let us discuss about what do you mean by into functions. What do you mean by into functions? Into functions is the functions which is not onto function. Let a function, please students note down the definition. A functions f is from a to b. A to b is an into functions, is an into function, which means into functions. Now let us recall the what do we mean by onto functions. Onto functions is the functions in which no elements of set B is left which do not have any codomain in set A. Then the reverse is the into functions. The functions which is not onto functions is called an into functions. Is an into functions if there exists an element, if there are at least one element, if there are at least one element in set B which do not have, having no pre-image in set B, having no pre-image in set B, image in set A, then this is called the into functions. Means the vice versa of onto functions is called into functions. Now take an examples here. Suppose A be a set and B be another set. Here A be a set and B be another set. Here A1, A2, A3, A4, A5 are the elements of set A, where here B1, B2, B3, B4 and B5 are the elements of set B. And if f is a function from A to B in such a manner that A1 is mapping with B2 and A2 is also mapping with B2, A3 is mapping with B3, A4 is mapping with B4 and A5 is also mapping with B4. Here B1 and B5 are left here which do not have any pre-image in set A. This shows that this is not an onto functions. This means this f is an into functions. F is an into functions. Now let us discuss another example here. If I say another example here. Suppose A be an set and B be another set. A, B, here A, B, C, D, here 1, 2, 3. Then if here A mapping with 1 and B mapping with 2 and C mapping with 3 and D also mapping with 3. Then here let G be a functions from A to B. Then look at here. If any elements is left in set B which do not have any pre-image in set A? Left? No, because each elements of set B have pre-image in set A. Here A1, then B2 and C3 and D3. This means no elements 1, 2, 3 all elements are involved here which has pre-image in set A. This means this is not an into functions, this is an onto functions. This is an onto functions. Now let us discuss about what do you mean by identity functions. What is the meaning of identity functions? At first we discussed about injection functions, then surjection functions, then bijection functions. The functions which is both injections and surjections are called bijection functions. Then we discussed about many one, when many elements of set A mapping with a single element in set B. Then we say this is a function of many one. Then we discussed about into functions. Into functions is the definitions vice versa of onto functions. The functions which is not onto is called an into functions. Now let us discuss about what do you mean by identity functions. What is the definition of identity functions? Identity functions is the functions in which fx is equal to x. Here Please students note down the definitions. If let f be a function from a to a such that fx f of a is equal to a, then we say this is an identity function. Then when f of x is equal to x for all x belongs to a, then we say that this is an identity functions. Now let us discuss about some examples. Let a is equal to a b c and f be a functions from a to a is represented in this way. This is x, this is y, this is set x, and this is a, and this is a. F b and mapping from a to a such that here a b c and here also a b c. A mapping with A, B mapping with B, and C mapping with C. This means f of A is equal to A, f of B is equal to B, f of C is equal to C. Then this is called identity functions. Which functions? This is called identity functions. This means fx is equal to x for all x belongs to A. Now let us discuss about constant functions. What do you mean by constant functions? Now let us discuss about constant functions. Constant functions is said constant functions. This doesn't matter what is in set A. This doesn't matter what is in set A. The functions has an unique mapping in set B. This may be A, B, C, and this is 5 here. F is called constant functions which mapping from A to B such that 1 mapping with 5, B also mapping with 5, and C also mapping with 5. This means fx is equal to constant functions fx is equal to C for all x belongs to A. This doesn't matter which is the elements in set A, but it has a constant order pair in set B. This is called constant functions. Suppose we say f be a functions from A to B such that f be a functions. Here f is 4, 5, 6 and B has 7, 8, 9. Then here f is a functions from A to B such that 4 is mapping with 8, 5 is also 8, 6 is also 8. This means f4 is equal to 8, f of 5 is equal to 8, f of 6 is also equal to 8. It's called a constant function. This doesn't matter which elements are in set A, but this elements has a constant mapping, constant image in set B. Then we say that this is a constant functions. Students, I think you can better understand about the functions. At first we discussed about injection functions, means 1 functions. Then we discussed about surjection functions, means onto functions. Then we discussed about bijection functions, the functions which satisfies both the conditions of 1 onto, means injection and surjections. Then we say that this is bijection functions. Then we discussed about many elements of set A mapping with 1 element in set B. This is called many one mapping. Then we discussed about into functions. Into functions is the vice versa of onto functions. This means the functions which is not onto is called into functions. Now we discussed about identity functions. Identity function says that fx is equal to x for all x belongs to the set A. And here we discussed about constant functions where fx is equal to C means constant for all x belongs to A. Now students, please practice your worksheets and ask me your doubt. I am ever ready to clear your all doubts. And dear students, if you have not subscribed my channel, please subscribe it. Thank you students.